Good morning, my dear JEE Advanced 2024 warriors. The next session is here of your physics with your captain Shreyas on the Vedantu JEE English channel. Welcome aboard. And today we'll be doing some amazing, top-notch, best questions from your modern physics and ray optics. So if you have missed attending our previous classes, remember in the live section you can just go through. I have done, in the previous days, light, waves, oscillation, sound, a special class for JEE Advanced. Then we have also done for mechanics, right from your vectors, kinematics to rotation, SHM, and then also electromagnetism, electrostatics, capacitor, current, electricity, magnetism, magnetic effects, right, and EMI. So all these things were covered over here. So make sure you are seeing all those previous lectures. It's there in the live section. Okay. So let's begin with this class with your captain Shreyas. I hope everybody is live and you have liked the video. That's very important. That's your daily ritual. Hello Jana. Hello Kanizad. Nice to see you back. Hello Sherry. Nice to see you back too. Be Prem. Welcome Maruti. Welcome everyone. And make sure you are sharing this video with your friends as well, so that they too benefit from these particular sessions, right? Okay. So I hope you have participated in the poll and actually liked, shared, and subscribe. Just don't say yes. Okay, done. Let's begin. Ready for the modern physics part? Tomorrow I will take a special class on the toughest problems. How many of you can solve it? That is something to be seen. Okay, we'll solve some really tough problems. Tough in the sense not lengthy, tough in the sense tricky. Okay, and that is what will help you boost your score. So let's see those questions in tomorrow's lecture. Okay, cool. Let's begin with the class. Awesome, Hiranmai. Very nice. Okay, fine. Everybody is live and everybody is seeing the class. Great. So here is the first question on your screen. You can see this is an optical fiber and it consists of two materials. The pink one, the one which is inside, which is called as the core, is μ1 refractive index. The cladding which is there, the protection, that core is surrounded by the cladding, which is that surrounding part. It is made of μ2. A beam of light which enters from here gets refracted and then totally internally reflected inside, because you can see μ2 is less than μ1. That means the one which is inside over here is dense medium. It is basically dense medium, and the one which is over here, this particular part, is nothing but rare medium. So that is the reason why this particular ray of light will get totally internally reflected at this particular point. The question is, what is the value of alpha? Straight away question, guys. I mean, just use geometry, draw the diagram properly, mark the angles. You will see many things will start falling into place. So here is what I will see. First of all, okay, I'll just draw a little bit bigger diagram. That's all for your sake. This is that interface between μ1 and μ2. This is μ1. This is nothing but μ2. And let's say this is basically the normal. And let's say this is that ray of light which came in. This is that ray of light which came in. This is that critical angle. This is that critical angle IC. On this surface, on this particular surface, you will see that the light has come from air inside this particular medium. So let's say the light came from air over here. And if I show the normal at this particular place, it will look something like this. So think about it. If light has to get totally internally reflected here, it has to get totally internally reflected at this point, then sine of that critical angle should be mu of the rare medium upon the mu of the dense medium. That is the formula. If you actually look at the original formula, it is 1 upon mu, okay, the refractive index of the dense medium with respect to the rare medium, So actually, if you see, this is nothing but mu d below and mu r on the top. mu d below and mu r on the top, because 1 mu 2 is mu 2 by mu 1. This is the formula, and it also makes sense because sine of any angle will always be less than 1. So this ratio has to be always less than 1. That means the numerator will be small, denominator will be big. So even if you don't remember whether r was on the top or r was below, don't worry. Always make the numerator smaller. So choose a smaller refractive index and choose a larger refractive index below, which will automatically make the ratio less than 1, because sine cannot exceed 1. That is mathematically only not possible. Everybody with me on this? Very good. Good morning, Akriti. Good morning. Okay. Now that's it. What is the rare medium? What is the rare medium? It is nothing but mu 2. What is the dense medium? That is nothing but mu 1. I have marked it over here. So that is basically sine of IC. The next part of the problem will be, look over here, if this is IC, this is 90 degree, this is basically a 90 degree triangle. So that means this angle would be 90 minus that critical angle. And if I use Snell's law over here, because this angle was alpha, this angle was alpha. So if I use Snell's law, then sine of alpha divided by sine of 90 minus IC will be equal to the refractive index relative to air and this inside medium. Inside medium is mu 1. So that's it. It is just going to be mu 1, because light is just traveling from air to the medium number 1. So this just has to be mu 1 by 1, which is just mu 1 only. That's it. Air's refractive index is 1. What is sine 90 minus theta? It is cos theta. So sine of alpha divided by cos of IC will be nothing but mu 1. I will just go on to the next slide. Sine of alpha is mu 1 times cos of IC. Cos of IC. Now how do I find cos of IC? Because I just know sine of IC. Sine of IC, remember, sine of IC was mu 2 by mu 1. From this, to find cos of IC, I can use this formula, which is the trigonometric identity. Sine square plus cos square is 1. So cos square is 1 minus sine square. So cos is root of 1 minus sine square. So cos is 1 minus sine square theta and the entire thing under the root. So it will be nothing but 1 minus mu 2 square by mu 1 square. So it will be nothing but mu 1 square minus mu 2 square, the whole thing divided by mu 1. So substitute it over here. Root of mu 1 square minus mu 2 square, the whole thing divided by mu 1, and the remaining term is just mu 1. Mu 1 cancels. So I am left with mu 1 square minus mu 2 square. That is sine of alpha. That is sine of alpha. Therefore, alpha will be sine inverse of root of mu 1 square minus mu 2 square. That should be the answer. Yes, sine inverse of root of mu 1 square minus mu 2 square. Like I said, draw the diagram properly, mark the angles, slowly things will start falling into place. That's exactly what happened in this problem. This diagram was very small, so I first of all take my rough sheet. In the examination, I draw a big diagram to get more clarity. I eliminate all the unnecessary things. I only concentrate on things which are necessary, like the total internal reflection and the refraction over here. For total internal reflection, I use the total internal reflection formula, which is the relative refractive index is sine of the critical angle. From that I got sine. Then I use Snell's law over here, and then I saw instead of sine I got cos. So the moment I get cos, I use trigonometry to convert the sine into cos and then substitute to get the answer. Loved the problem? Everyone? Okay. Alright. Salini, mains is over. What about mains? Anushri, I'm very good. Got it, Canizard? Very good. Excellent. Just asking, if you are just asking how many questions will come, nobody knows. But there will be majority of the questions will come from mixed concepts. So something of optics, something of electromagnetism, something of mechanics. So mixed concepts might be there. So you cannot really ask, what is the weightage of this chapter in advance? That is an invalid question. Just like 2 divided by infinity is not 0. 2 divided by infinity is basically, or any number divided by infinity is not even a number. It is not defined. So there is no point only asking what is the weightage or the syllabus, marks from this particular thing. No point. Nobody knows. Okay. This question, the energy levels of the hydrogen spectrum is shown. There are some transitions A, B, C and D and E also. A, B, C are respectively which ones? Think about it. A, B and C. Come on. A transition means this one. A is this transition. Come on. What is A going to be? Figure this out. Figure this out. Come on, my dear warriors. Everyone. All right. Akriti, if you have just passed 10, the best batch for your preparation to join offline, I would say, Akriti, if you are in any of the cities where Vedantu Learning Center is there, go visit these centers, because today is the last day of the trial classes which are going on in the offline center. So just go there, experience the Vedantu Learning Center. Number one. Number two, there is up to 90% scholarships which are offered at these centers, and the offers are ending, I think, today or by maximum tomorrow. Third, check out the centers, see the teachers, and most of the centers we have been visiting also these days. Many centers in Tamil Nadu, in Maharashtra, in Karnataka, we are going to come on 24th, right? So a lot of these centers we are visiting. Even in Hyderabad, I've made a visit. So check out these centers, because you have top-notch faculties. You also have visiting faculties just like us, right? Who is going to help you. So check them out. You will get material, everything. Okay, that's what I would say. And if you are already passing out, do let them know about Vedantu Learning Centers, because many of them do not even know Vedantu has offline centers. So it is your job as a passing out student to let students know and create awareness. So where is A? Come on. Where is A? I think it is Lyman series, and it is the last line of Lyman, because n is 1 is Lyman from infinity. So last line is series limit of Lyman series, series limit of Lyman series. So this is either C or D. Option number A and B got eliminated. If you check option number B or line number B, what is line number B? Come on, guys. What is the line number B? What is the line number B? It is Balmer for sure. It is Balmer for sure. N is equal to 2. First line, second line, third line. So third line from Balmer, third line. So Balmer series is there, but this is second line. This is wrong. This is third line from Balmer series. This is perfectly fine. So I think it is option C only, but for verification, we can also do for line number C. What is this line number C? Lyman, Balmer, Paschen. First line, second line. Paschen, second line. Paschen series, and it is the second line. Perfect. Third spectral line of Paschen, this is wrong. So option C seems to be correct. Okay, D and E were not even required over here. So option number C. How many of you marked it as option number C? Very good, Sri Krishna, Canizard, awesomeness. Awesomeness. Very good. No problem, Anushri. Okay, moving on to the next one coming up on your screen. A radioactive isotope. I hope you know radioactivity is a part of JEE Advanced. I have done that additional portion for all of you in the last month. Okay, a radioactive isotope has a half-life of this much, and it converts into Y, which is stable. Some sample of that material from the rock of the moon was found to contain both X and Y, which were in the ratio of 1:7. What do you think is the age of the rock? So think about it this way. Think about it this way. The rock originally would have contained only X. Okay, and then after some time, there was a small amount of X remaining. There was small amount of probably X remaining, and most of it was Y, which was the stable compound. Here the value of Y was 0. All this I'm talking about at t is equal to 0, and this is at t is equal to some time, which we have to find actually. That is exactly the question. So imagine if the ratio of the X and Y compounds which were found in that rock after some time is in the ratio of 1:7. So if this is A units, then this will be basically 7A units If a number of molecules or compound amount is present of X, then 7a is the amount of Y which is present in that rock material. So if you go back in time, Y was 0, so by conservation, obviously the total amount present initially would have been just nothing but 8 times of A. Would have been nothing but 8 times of A. A plus 7a is 8a. So 8a got decayed, A was left, 7a was created into the stable compound. So this was the original rock. So how much time elapsed will be the age of the rock. So to find the age of the rock, we have to find how much time has passed by. Now remember that formula which we have. Remember the formula which we have, which is nothing but n is equal to n naught into e to the power minus lambda t. So you can just write log of n by n naught is nothing but minus lambda t. Therefore lambda t will be nothing but log of n naught by n. When I take the minus sign inside, the inside of the log term flips, reciprocal of that. Okay, so the minus sign has been taken inside. What is lambda? Lambda is not given, but the half-life is given. So it is a log of 2 divided by the half-life into the t. This t will be the age of the rock, is equal to log of n naught divided by n. Log of n naught divided by n. Do I know the value of n naught and n? Yes. N naught is the original sample amount, which is basically 8a. Final sample left is just a. A and a gets cancelled, it will become log of 8. So therefore, it will become log of 2 divided by half-life, which is 1.37 into 10 to the power 9, okay, into the age of the sample is equal to log of 8 is log of 2 cube 3 power comes outside and log 2 remains inside. That's it. Log 2 cancels, log 2 cancels, and the age of the sample will be 3 multiplied by this whole number, which is 1.37 into 10 to the power 9. 10 to the power 9. Guys, 3 into 13 is 39. So it will be slightly more than 3.9. So must be close to 4. So directly I feel I can mark the answer as B without even calculating. Yep, it is 4 point something. Yeah, it can't be 3.8 because 13 3s are only 39. So it has to be more than 3.9 and 1.37. So 13.7 into 3 will be definitely more than 3.9, which is definitely option B. Directly you can mark it. Understood without calculation how we did it? Everybody with me? Perfecto. Awesome. Let's go to the next question on your screen. Remember, radioactivity was not there in your JEE mains. It is there here. That's the reason why I thought I will make you practice these questions. Okay? That's the reason I have kept some additional content syllabus which can come in your JEE Advanced. In fact, even remember we did some amazing question on electromagnetic wave also in waves and sound part, if you remember. And electromagnetic waves was usually deleted in JEE Advanced. It was there in JEE mains. So now they have started asking questions on that. So see that question. It's a very important question. You will learn a lot from it. Okay. So all these classes will add up at least few marks. And remember in JEE Advanced, I mean few marks only makes that difference, because it's not like people score full out of marks in all the subjects. Forget all the subjects, not even in one subject. Even if you get 60%, 50%, 70% marks of the total marks, you are already in the good batch. You are already in the good bunch of students for JEE Advanced. Remember that. Right? Okay. Let's see. On this time, yep. Let's start. Let's start with this particular question. So it is clearly mentioned the atomic mass number is 180 and the atomic number is basically 72. What does alpha particle do? What does alpha particle do? Alpha particle subtracts the atomic mass number by 4 and subtracts the atomic number by 2. So what is remaining is basically 176, and this will just become 70. Then there is a beta particle. Beta particle does not do anything to atomic mass number. It just increases the atomic number by 1. So that's why this will become 71. This will remain as 176. Again, there is an alpha particle. it removes the atomic mass number by 4 and atomic number by 2. So what remains is basically 172, and this will just become, 69. What does a gamma particle do? It does not do anything. So it just remains as it is, as 172 and 69. 172 and 69. Keep this in mind, right? And remember, sometimes you might get beta plus particle. I know there is no beta plus here, but just by chance, imagine if there was a beta plus particle, then what would it do? If there was a beta plus particle, then it does not do any damage to the atomic mass number, but atomic number, it reduces by 1. Atomic number, it will reduce by 1. So this will be 172 and this will be 68. This will be 68. So beta plus reduces the atomic number by 1. Beta negative, which is your normal beta particle, increases the atomic number by 1. So that's something which you should keep in mind. Okay, everybody with me? Let's move ahead to the next question. Yes, option A is correct. In a photoelectric effect, frequencies are 𝛎1 and 𝛎2 for two different light waves falling on the metallic surface. So once you use one type of light, second time you use different color of light. The kinetic energy is in the ratio 1:k. Then the threshold frequency, that means I need the work function to find the threshold frequency. So always start with your energy equation, photoelectric equation, which is nothing but energy of the photon is nothing but work function plus the kinetic energy, So first time the frequency was 𝛎1, work function I can just put it as hf0, kinetic energy let me just put it as E. Second time the frequency is 𝛎2, work function is obviously the same, but the kinetic energy is in the ratio 1:k. So second time the kinetic energy is k times the older kinetic energy. So it is k times of the older kinetic energy. It is not ke. It's not kinetic energy. It is k times of E. Don't get confused. And some people might have written kinetic energy like this. So then it will look like KKE. So you need to be careful with the symbols. It's not like every time your comfortable symbols will only come in the exam. If that happens, if the symbols are very weird, you can change the symbols and solve the problem, as per your wish with your comfort zone. And in the end, do not forget to substitute back it to the original symbols. Or you should be very clear what these symbols mean when you are solving it, or else you will make some silly mistake. Okay, so the game of symbols is also a very, very tricky thing to handle in the exam, because there is always that dilemma: should I go with the symbols that I use, or should I change the symbols and revert it back in the end? I generally prefer solving the problem in my comfort zone and then probably getting it back to the original one. Okay, usually, but sometimes I'm okay if I know the length of the problem is not too much and immediately I can switch it back. So depends on the problem. Okay, I want to get rid of E because E is not there in the answer. So I have an idea. How about I take this particular equation? And I multiply it by K. So if I multiply it by K, it will become K times of h 𝛎1 is equal to K times of h f0 plus K times of E. Why did I do that? Is because if I subtract them now, this and this, KE will get cancelled, which I do not want only anyways. So that's the reason why I subtracted and I multiplied by K on both sides. Okay, I want F0, so I cannot get rid of F0. A lot of you would have thought, sir, let's subtract these two because HF0 will get cancelled. My dear friend, I don't want to cancel F0 because I want to find F0. So that's the reason why I multiplied by K to remove the E term, because it is not there in any of the option. Now let's subtract these two. And see what do we get. So here I will get H is common, K 𝛎1 minus 𝛎2 is equal to H F0, and I will have K minus 1. K will get cancelled, you will get 0. H will get cancelled. So I will get K into 𝛎1 minus 𝛎2 is equal to F0 into K minus 1. Therefore, F0 will be K times of 𝛎1 minus 𝛎2 divided by K minus 1. I think that is exactly what I need, which is option number B. B for IIT Bombay. Very good, Chandana. Excellent. Lucky, I'll tell you something, my dear friend. JEE Advanced is not the tough exam. It's not at all a tough exam. JEE Advanced is an exam for those students who make that exam or make the subject interesting. So if you solve the problem thinking, this is what in real life I might have to do. This is what, it's not a question anymore for you. It is no longer a piece of paper for you. It is just something what you might be dealing with in real life. If you remove the thought that, oh, where I will use this, I'm going to be a material engineer, I'm going to be aerospace engineer, I will not need chemistry. Okay, I don't need mathematics, I'm going to do this. Okay, I don't need physics, I'm going to do this. Those thoughts should be out of your head. You need everything to pass through the gate, to pass through the portal and go on to the other side, which is your IIT campus. And once you're inside, then all these things will not matter to you. Oh my God, sir, I wasted this. I wasted my time studying this part. I took this branch. Why did I even do that? All these thoughts will never come to your head, or should not even come to your head. So understand, it's just required for all of you to go on to the other side. Once you're on the other side, the feeling that you will have and the photo that you will post on probably your social media account standing in the front of the gate of IIT. And students send me every year. Not one, two, but tens and hundreds of students send their photographs, or sometimes they don't send, they just keep it, and I happen to see it. Okay, so you are posting your photo in front of the gate of the IIT. Isn't that what you are craving for? So guys, push yourself. Don't let any demotivating factor affect you. Don't let any of the nervousness affect you. It's just a matter of week. Next week you will be free birds. That's all. Right? How many of you are going to post a photo in front of the gate of IIT? Put up a heart in the chat box quickly. I want to see that fire or that josh. That feeling only will be very different, right? Correct. Very good. Chalo. Let's continue with the next question on your screen. Okay, we have an X-ray tube operating at some voltage and current, and the target material has some mass and some specific heat capacity. Some electrical energy is converted into 1% of the supplied power is converted into X-rays, and the remaining energy goes into heating the target. Then which of the options are correct? This is a question on Coolidge tube. If you do not remember what is Coolidge tube, or you have forgotten what is Coolidge tube, let me remind you, on this channel only I have done Shreyas Sir Advanced Extra. If you just search for this, Shreyas Sir Advanced Extra, see this, JEE Advanced Additional Topics of Physics. I conducted 5-hour class on all the additional topics which are there. So please check it out. Oh wow, what a, okay, after this ad you will probably see it. It's a big ad. Yeah, so you will be able to see. I have taught all these things, Coolidge tube, everything I have taught you. Okay, so please check it out. It's a very, very important lecture. Okay, all the additional topics which were not there in mains, but it was there in advanced. Now let's solve this particular question. Probably I might need a extra slide. Just 1 second. Okay. First two options are very straightforward. Suitable target material must have high melting temperature. It kind of makes sense because the electrons which are there, those electrons are basically accelerated. They are accelerated by a large voltage difference, so that they hit the target material. With high energy, and this target material is always cooled with some coolant or some water or some liquid which will absorb that heat and keep the target cool, or else it will melt. So definitely the target material should not melt. That means it should have high melting point. The target material should have high melting point. Definitely option A is correct. Definitely option A is correct. What about this particular option? A suitable target material must have low thermal conductivity. That means it should not conduct heat. I feel that has nothing to do over here. And why low thermal conductivity? I mean, even if it has high thermal conductivity, it is good only. In fact, it will conduct all that heat into that coolant. Or else, if it has low conductivity, then probably, it is not going to conduct that heat from one side to the other side, where the coolant will absorb that heat and let it go. So having low thermal conductivity does not make any sense. The average rate of rise and the minimum wavelength. Okay, both these things. So minimum wavelength we can find out very easily using this equation. hc by lambda is basically E times of the voltage by which you have accelerated it. So this is basically, if you write it in the proper order, you will like it. Kinetic energy is going to get converted into basically the energy of the photon. So kinetic energy of the electron, which is nothing but your charge into the voltage difference, is energy of the photon, which is hc by lambda. So this is basically your minimum wavelength, the cutoff wavelength. So lambda minimum will be hc by E, and you will have 1 by delta V over here. In fact, hc by E is a standard value 1.23 into 10 to the power minus 6. How do I remember it? 1, 2, 3. It's in order, right? And 1 into 2 into 3. 1 2s are 2, 2 3s are 6, so minus 6. So 1, 2, 3, 2 into 3 into 1 is 6. So that's how I remember it. Very simple. Voltage difference is 50 kilovolts. So 50 into 10 to the power 3. Just do the math and see how much does it come out to be. Just do the math and see how much does it come out to be. I think this will be 1 by 5, or if I do it as 0.5, it will become 2 times. So 2 into 123 will make it 246, 2.46. So I think close to this. Yes, option D is correct, guys. Option D is correct. How many of you got it? Option D is correct. Everyone? Everyone? Did you see option D is correct? Can you confirm that? Yep. Very good. Very good. Awesomeness. Awesomeness. What about option number C? Only C option is remaining. So for that, I will go on to the next slide. I'll tell you what. The target material, okay, will get heated up. And if you do not cool it, the temperature will keep rising because it is absorbing the kinetic energy. And where is that kinetic energy coming from? From the acceleration. And how much kinetic energy are you giving? How much energy is being supplied into that Coolidge tube? I can do one simple math. This is voltage. This is the current. Voltage by which I am accelerating multiplied by the current will give me the power supplied. So the power which is supplied will be the voltage by which you are accelerating multiplied by the current, and only 99% is going into heating, 1% is going in creating the X-rays. So 99 by 100 of Vi is going into heating, And when I say heating, that means I can put it as dq by dt. This q is the heat, t is basically your time. Remember, this is power. Power is joules per second, watts, energy per unit time. So this is dq by dt. So what is dq? dq, I can write it like this, d by dt. Q is itself ms your t, or ms delta t we can put it as. ms delta t. Where is it? ms delta t, right? ms delta t. M and S is constant, so comes outside. So it will become ms, rate of change of temperature with respect to time. And here we have 99 by 100 multiplied by voltage multiplied by current. So dt by small t, dt by dt is basically 99 by 100 into voltage. Voltage is basically 50, kilo is basically 10 to the power 3, into current. Current is basically 20 milli, which is 10 to the power minus 3. Whole thing divided by mass. Mass is basically 1 kg. Specific heat capacity 495. So how much will dt by dt come out to be? 10 to the power 3, 10 to the power minus 3 cancel. 50 into 200 into 10, 1000. So 1000 here and this over here. Okay, so 2 zeros cancelled. Oh, this is just coming out close enough. 99 and 100 are almost like 1, guys. This ratio, this number is almost like 1. So forget this. So this is almost coming out close enough to 2. Yep. So 2, what is it? Change of temperature. So degree Celsius per unit time. So per second. So yes, option C is also correct. So option C is correct. D is correct. A is correct. B is wrong. So except for B, everything is correct. We have got it. Except for B. Everyone? Okay. Very good. Awesomeness. Awesomeness. Everybody, shall we go ahead? Everybody, let's go ahead. Awesomeness. Let's go. Perfect. And keep liking the video. If you have not liked the video yet, you have not given the Guru Dakshina, then whatever you learn, right, will never enter your head. And when you need that knowledge in the exam, it will never be useful. So always remember, not just for me, for anyone, whenever you learn something, you need to give your Guru Dakshina in whatever form it is asked by your Guru or whatever, you feel is comfortable. So I'm asking you, smash the like button, share this video, recommend this channel to your friends, to your batchmates, to your colleagues, to your juniors, to your cousins. You have to do that. That is your Guru Dakshina when you are attending the class on YouTube over here. This is the channel for you, the only JEE English channel in the country, and we have been working really hard for this for the last 2-3 years. Okay, moving on. Next question. Refraction takes place on a concave spherical boundary separating glass and air medium. The refractive index of glass is 3/2. The radius of curvature is r. For the image to be real, the object distance should be greater than IR, where I is integer. Find the minimum value of I. Okay, let's try to do this. Okay. Sir, when to use that 931 mega electron volt? 𝒎𝒏, it is for mass defect. When you destroy one atomic mass unit, then the energy released is basically 931 mega electron volt. So that is in nucleus chapter. That was in nucleus chapter. This is not nucleus chapter. This is basically your photons, right? Photons and atoms chapter, X-rays. So completely different thing. So this number is the value of hc by E. If you put it in SI units, 1.23 into 10 to the power minus 6. Cool? Okay. So how about this particular question? How about this particular question? Come on, come on. Think about this. What do we do over here? First of all, draw the diagram, because diagram is not given. That's the first thing that should come to your mind. Okay. So there is a concave spherical surface separating glass and air. Okay. So this is your concave surface. This is your radius. This is your, no, separating your glass and this thing. Yeah, correct. Glass and air, and the object will be here somewhere. This is basically your object. Perfect. So the rays of light will go like this. The rays of light will go like this. And I want that the image has to be real. See, there will be some object distance. There will be some object distance for which the image is virtual. Imagine the object is placed somewhere when the image is basically virtual. There will be some object distance. There will be some object distance when the image is real. In between these two, there will be another object distance, which I call it as the critical object distance, where the image is neither virtual nor real. I keep moving the object from infinity to close to the boundary. Some places the image will be virtual, then after some point the image will become real, or some place the image is real, then the image will become virtual. When that transition happens, what the kind of image will be formed? Because if it is virtual, remember, the rays are not converging, the rays are diverging. When the image is real, the rays are converging. So from your diverging rays, and converging rays, in between that there is a transition which happens where the rays are just parallel, that means no image is formed. No image is formed. So I'm going to solve the problem now for this particular critical case. This is my critical case for which I need to solve the problem. This is the critical scenario for which I need to solve the problem, because this is that distance for when the transition will happen. Is this point clear, everyone? Is this point clear, everyone? Give me a thumbs up in the chat box. So the rays are going to be just parallel. That is the simplification of the problem. The image is formed at infinity, and the formula that I need to use is 𝜇2. Where is it? I'll put it over here. 𝜇2 by V minus 𝜇1 by U is equal to 𝜇2 minus 𝜇1 divided by R. So let's start substituting and solve the problem for that critical case. 𝜇2, the second refractive index is of air, so 1. V is image distance, which is at infinity, so by infinity, minus 𝜇1 of the glass has a refractive index of 3 by 2 by object distance, put it as U, is equal to 𝜇2, air minus glass, divided by radius of curvature, which is just R. Perfect. 1 by infinity is 0, so this will become minus 3 by 2 times of U is equal to 1 minus 3 by 2 is minus half, so minus half and 2R over here. Minus 2 gets cancelled. I'm just left with 3 by U is equal to 1 by R, rather U is equal to 3R. Perfect. I think I found the answer. The object distance should be 3 times of R. This 3 is that integer. This 3 is basically that integer which I was talking about. So the value of integer is 3. Answer is 3. Perfect. So this analysis was very important in the beginning. Only then I could substitute. Nobody will tell you what you should substitute. That is what JEE Advanced is. It's not like 𝜇2 will be given, V will be given, 𝜇1 will be given, U will be given, R will be given, substitute and find the answer. It's not mains level problem. You only have to figure out, okay, what the diagram will look like. Okay, what is the value of V? What is the value of U? Okay, how do I interpret the problem? For what situation is this problem made? Those things you will have to think. And that is what we did initially before we use formulas. So don't jump always to just use the formulas. That is not going to be of any help in JEE Advanced. Analyze, draw the diagram. Yeah? Okay. R will be positive, Veena, because R is on that other side, right? Positive side. Okay. Very good. Very good. Awesomeness. All right. Let's move on to the next question coming up on your screen, and here it is. In Rutherford's scattering experiment, the number of particles observed at an angle of, now this is a very interesting problem. Many of you, if this question comes in the exam, you will probably be baffled. At an angle of 10 degrees is 1 million per minute. Find the difference of the number of particles approximately per minute that will be observed at angles of 90 degree and 180 degree. Wow, what a question, guys. What a question. See, in Rutherford's alpha ray scattering experiment, if this is the, let's say, nucleus, if this is the nucleus, okay, some particles will get deflected by 180 degrees, some particles will get deflected by small angles, very few particles will not will be deflected by 180 degrees or very large angles. All these things you have seen in atomic structure. So if any particle comes and it gets deflected, okay, some particles will just do U-turn. Most of the particles will just get deflected by a small angle. Some particles will not be deflected at all. Okay, so the angle by which they get deflected has a formula. Now, do you know that formula or not is the question. So the formula is as follows. It is nothing but the number of particles which are deflected for a particular angle is some constant divided by sine raised to 4 of the angle which you are considering divided by 2. This is the formula which you need to know for your scattering experiment, your Rutherford scattering experiment, right? Alpha is the angle at which the particles are scattered. How many particles are scattered? This number is given by this particular formula. If you know this formula, then your job is done. Yes. If you know this formula, then your job is done. How do we do this? Observe now. For the first scenario, for 10 degrees, for an angle of 10 degrees, the number of particles is 1 million per minute, is 1 million per minute. Okay. So basically 1 million is nothing but 10 to the power 6 per minute. Okay, that's always per minute. Okay, is equal to this constant divided by sine raised to 4. Alpha is basically 10 degree divided by 2. Therefore, the value of k is 10 to the power 6 into sine of 5 degree, the whole raised to 4. The whole raised to 4. So, k value was never given, but it was found out given using this information. Using this particular information, we have found it out. Is that clear, my dear warriors? Now, let's write it down for 90 degrees and 180 degrees. For 90 degrees, N90 will be k divided by sine raised to 4 of 90 degrees divided by 2, which is this k, I will keep it as it is for now, k divided by sine of 90 by 2, which is sine of 45. Sine 45 is 1 by root 2. 1 by root 2 whole raised to 4, which is k divided by 1 by root 2 square is 1 by 2. Square of that is 1 by 4. So it is just going to be 4 times of k. It is just going to be 4 times of k. Then the number of the number of particles which are going to be scattered at 180 degrees totally will be k divided by sine raised to 4 of 180 degrees divided by 2. Now the best part is sine of 180 by 2. 180 by 2 is 90. Sine 90 is 1. So 1 raised to 4. 1 raised to any number is 1 only. So it will be just k. Now read the question carefully. You will understand what is asked. 90 degree and 180 degree. You have to find the difference. Find the difference. That's it. So the difference what we are talking about. The difference what we are talking about. Okay. So just keep it on the side. Is nothing but 4k minus k, which is 3 times of k. But k value is right over here. K value is right over here. So 3 into 10 to the power 6 multiplied by sine raised to 4 of 5 degrees. How do you find the sine of 5 degrees? Do you know the value of sine 5? No, right? Obviously. So convert 5 degrees into radian. So sine of 5 degrees will be sine of 5 pi by 180. Everybody with me on this? Everybody with me on this? Clear? Why did I convert it into radians? You might be thinking. Don't worry, I'll show it to you. But first of all, what is 5 and 180's division? 180, 36. Yes, 36. This is in radian. This is in radian. Why did I do this? Because when the angles are small, sine theta is a theta for those small angles in radians. So therefore, this will be approximately sine of 5 degrees will be approximately the angle in radians is as it is, so pi by 36. Pi by 36. So therefore, the previous part of the question continued. If you do, this will be the difference. That particular difference will be nothing but 3 into 10 to the power 6 multiplied by 3 into 10 to the power 6 multiplied by sine raised to 4 of 5 degrees. So pi by 36 whole raised to 4. Whole raised to 4. This is a very small number. When you do the math, you will get the approximate difference to be 173. Yes, approximately 173 will be the answer. Just do the math. How many of you would not be able to do it? Sir, they will give, right? What will they give, Canizard? What will they give? The value of k will not be given. This formula, you remember it now. If you have not learnt it before, you have not seen on any YouTube, I am telling you, remember this formula. Okay? If this question comes, you know how to do it. Hopefully this question, if at all it comes in passage and this formula is given. But you never know. It's JEE Advanced. You cannot catch their neck and tell, oh, where is this in NCERT? They will be like, who the hell are you? I will give out of NCERT questions. Nobody can question JEE Advanced. They can give anything. It's their wish, right? So keep that in mind. It's not NTA. Remember that. It's not NTA. Yep. Sine 5, what? No ways. How will they give sine of 5 degrees? No. You have to use your brains. You have learned maths, right? You know sine of small angle approximation. So you cannot say, sir, I learned that in maths. This is physics paper. I thought I cannot use it. Obviously, you cannot say such things. You have to use chemistry knowledge. You have to use maths knowledge if required in physics. You cannot sandbox all these 3 subjects. Whatever happens here will not affect the other thing. You cannot do that sandboxing. You have to use interrelated subject knowledge. Convert degrees into radian. Radian, I know sine theta is theta. So, sine theta is approximately theta if this theta was in the radians. Obviously. Got it, everyone? Let's move on. Let's move on to the next one. The electric potential between proton electron is given by where V0 and R0 are constants. R is the radius of the electron. Assuming Bohr's model to be applicable, it is found that R is proportional to something where n is the principal quantum number. Find the value of x. Okay. So it is found that R is proportional to n raised to x. Okay. Where V0 and R0 are constants. R is the radius of the electron. Where is that given by? I think something is missing, guys. I think something is missing. Is given by where V0 and R0 are constants. R is the radius. I think that formula is only missing. Okay, I'll do one thing. I will put the correct version of the question and give it to you as homework. Okay, something is missing over here. Is given by. Okay, so I'll give it to you as homework later on. I'll post the correct question and I'll try to also paste the solution later on. Okay, for now let's just skip it. The answer comes out to be 1. I don't know what the actual question is, but I'll just tell you what could have been there. I don't know what was the actual question. Just chumma, I'm guessing, random thing. If the electric potential is given by K by, let's say, something, K by R or K by R square, K by R cube, could be anything. Let's say K by R raised to N. Then electrical potential energy will be given by Ke divided by R raised to N. Then from this you can find the force. The force will be negative du by dr. So it will be Ke with negative sign. Derivative of R raised to N. Derivative of R raised to N, which is nothing but minus Ke. N will come over here. R raised to N minus 1. Now this force you will equate it to. This force you will basically equate it to mv square by r. mv square by r. That is what you will equate it to. From this you will get velocity relationship with radius. Another equation which you will use is angular momentum is nh by 2 pi. So angular momentum is mvr. This is equal to nh by 2 pi. How did I say this? Because Bohr's model is applicable. That's why angular momentum is nh by 2 pi. So v will be nh by 2 pi mr. So use this velocity, substitute it here. Solving this, you will get the value of r is equal to something. Our value of r is that n which is there, right? This principal quantum number. So r raised to something. Actually this n and that n are different. Hold on. Okay. So I think I should use some other value. 1 second. Don't get confused between these two n's. These two n's are also completely different. R raised to alpha, R raised to alpha, R raised to alpha. So alpha minus 1. Okay, now it is fine. This n is the principal quantum number. Alpha is some power. From this you will get R is basically, n raised to something. N raised to something. That's something you can find it from here. Okay, that's something you can find it from here. R is proportional to n raised to something. That is what you have to find. That something is basically that x. Something is basically that x over here. You need to understand the procedure from potential energy to force by du by dr. Force is equal to centripetal force, so it is mv square by r. Angular momentum is nh by 2 pi. From that you get velocity. Substitute the velocity. Solve this, you will get the answer. Cool. Okay. Fair enough. Let's move to the next one. Wow. Bohr's atomic model for hydrogen-like atoms match the following. Come on. Electron jumps, electron jumps, electron jumps, kinetic energy, speed, angular momentum, angular velocity. None of these. Okay, we should know everything. Speed of the electron is proportional to z by n. Z by n. Then kinetic energy is basically negative of total energy. So it is directly proportional to z square by n square. Then angular momentum is nh by 2 pi. So it is directly proportional to n. Angular velocity omega is proportional to v by r. Velocity is inversely proportional to n. R is directly proportional to n square. So it is directly proportional to 1 by n cube, or inversely proportional to n cube. So these are the formulas that I will need for solving the question. So check for option number A, guys. Electron jumps from 2 to 1, 2 to 1. So n became half. If n becomes half, speed will double. Speed will become 2 times. So A option will definitely go with P. And n square, n will become half, kinetic energy will become 4 times. Yes, even Q option is correct. Angular momentum, no, will not become 2 times. Angular velocity will become 4 times, no. So A is going with P and Q. A is going with P and Q. Are you able to see that? Are you able to see that, my dear warriors? Yes, very good, very good. Awesomeness. Everyone? Very good. Next, what about electron goes from 1 to 4? N has become 4 times. So speed has become 1/4 times, wrong. Kinetic energy, it will become, 1 by 16 times. Angular momentum will become, 4 times more. Angular velocity, no. None of them is matching. So none. Oh, interesting, guys. So B option is matching with none of these. B option is matching with none of these. Let's go to the last one, option C. Electron goes from 4 to 1. N has become 4 times less. So velocity will become 4 times more. Kinetic energy will become 16 times more. Angular momentum will become 4 times more. 4 times less, my bad. 4 times less. And then angular velocity will become 4 times more. No, this is 4 cube. 4 cube is 64. Definitely not. So again, this is also none of these. None of the options are matching. So sometimes this kind of things can also happen where multiple options are matching to T and these options were not even useful. Don't get scared. Sir, I have done something wrong. Okay, it might be correct. Let's find out. A is with P and Q. A is with P and Q. B is with T. C is with T. That is none of these. Perfect. A is with P and Q. B and C is with T. So R and S were not even selected. So if such things happened in the actual exam, don't get scared. You might be correct. It's just that you need to be confident while marking it. That's all. Okay. Let's do the next one. Definitely Baswa ready for all of you only. Very nice. Thank you so much. Okay. Any trick to remember these formula? They are all a bit confusing. Varshita, I'll tell you, there is a beautiful formula revision class which I had conducted. Just check it out. I don't know how many of you have seen it. Just search for formula Shreyas. Just search for formula Shreyas on the channel, not here, in this part. If you're on the mobile, it might be slightly difficult. You can see this. Okay, complete physics formula revision. I have not done it the regular way. I have done it in a very innovative way. Okay, this formula revision technique, nobody, I will tell you, has done on YouTube the way I have done it. Watch this, you will remember everything. Also in the link of the description and even the comments, you will see there is a PDF attached. So check out this class is what I will tell you. Okay, complete formula revision. Okay, it's there right over here. This one, use this one. This is the old one. This was 1 year ago. This one, okay, 101K views. This is the one which you will see. This also you can use, but that is based on the old syllabus, which is still okay because you still have old syllabus in JEE Advanced. Okay, perfect. Yes, matrix can have multiple answers also. Matrix can have multiple answers. Moving on, next question. Come on guys, this is very straightforward. Everybody should be able to mark it. What will option A go with? What will option A go with? 5 to 2. Lyman-Balmer. I think it will be Balmer series. Just check this out. Okay, everybody. What is 8 to 4 going to be? What is 8 to 4 going to be? Lyman-Balmer Paschen bracket. Yes, so it will be bracket series because it is going to 4. C, 3 to 1. 3 to 1. Come on, my dear warriors. First one is the Lyman series. So it will directly go to P option. And the last one from 4 to 3. Lyman-Balmer Paschen. Paschen, that is R option. So that will be this one. That's how the match the following will be. So nice, beautiful colors. But that is not how you are going to mark it. In the exam, you are going to select properly. Okay, you will not be given options. Remember, you will be just given blanks. Dot circles will be there. You have to choose. A is with P, Q, R, S will be written. You will select. A will be with S. B. Okay, P, Q, R, S will be given. You will select Q. So it is a time consuming process. Remember that. Okay. So that's it. What about this question? Ray optics, guys. I think an object is given and the LHS on the LHS various velocities of the object and positions are given, and the properties of the image and its velocity are given on the right hand side. Question is, how will they change? I'll tell you. Let's read the question and then let's figure out. Positive velocity object is between focus and center of curvature. Negative velocity object is between focus and pole. Negative velocity object is between center of curvature and beyond center of curvature. Negative velocity object is virtual. Okay, positive velocity, negative velocity, size of the image, size of the image. Okay, I'll tell you what, a simple way to do this. Do you think you will do this question using formulas? Do you think you will do this question using formulas? Definitely not. Why will you not do this using formulas is the question. Because it is going to be time consuming. Instead, I feel you can do it using a trick, and that is a diagram. And I think I had put one diagram. Yes. This is your ray diagram for different positions of the object and where the image is. When the object is very far away, the image is formed, highly diminished, and it is at the focus. As the object comes closer towards the center, you will see the image starts moving away from the focus towards the left hand side. The image slowly grows in size and it is inverted. I hope you can see that. Okay, if you want, I'll show the different positions of the image. The image is here, then the image is here. Then when you are at the center of curvature, it's of the same size, but it is inverted and going towards the left side. You bring the object closer towards the focus, the image becomes even larger now. It's larger than the object and it is going towards the left side. Finally, when you bring the object at the focus, the image is formed at infinity. And when you bring the object beyond the focus towards the pole, then the image is now virtual. The image is now virtual. So let's see the different positions of the object also. Here this is the object, here this is the object. The green one is the object, remember that. The green one is the object. Keep that in mind. Okay. Remember, here the object was at infinity. Here the image was at infinity. Now check the first option. Check the first option. Positive velocity object is between focus and center of curvature. Object is between focus and center of curvature. That means you are talking about this particular option, my dear warriors. This particular option. You are talking about this one. So if that is the case, object is between focus and the center of curvature. Object is between the focus and the center of curvature. And the object has positive velocity. That means this green part is moving this side. Where will this yellow part go? It will go towards the left side. The image velocity is towards the left. The image velocity is towards the left. And as it goes towards the left and it reaches the center of curvature, the image is going to become big. From small image, inverted, it will become a big inverted image. So, which are the correct options now? Which are the correct options? Obviously, oops, sorry, I gave the answer. Okay. Obviously, the image velocity is definitely negative. Image velocity is definitely negative. Also, the size of the image is increasing. The size of the image is increasing. So that is the first correct option. You can see as that green one comes here, the yellow one will go big and it will go towards the center of curvature. So in that particular option, you can see that the object is slowly moving here, and this image which is inverted is growing in size, and it is also going this way. So it is growing in size and going towards the negative side. Hence, the correct answer is negative velocity and the size of the image is increasing. This way you can mark all the other options. This way you can mark all the other options. Understood? Guys, those of you who are going to spam over here, you will get blocked. Make sure that you are not spamming over here. Yes, you will directly get blocked. Make sure that you are not spamming over here. Yep. You can see the admin is already blocking many of the students, and that is very simple, guys. It's very straightforward. We do not entertain any kind of flirting and spamming out here in the chat box. This is a serious channel. That's it. As simple as that. If you want to go flirt, please download some apps that will be probably helpful and become a loser in life. You can be a loser in life. Go ahead. Who is asking you to sit and study and waste other teachers' time and other students' time out here? Go spend your time somewhere else. Go to the movie theater, go to the restaurant, go to the, I don't know what you guys do, because I've never been such a loser in life. I never met or never had friends also who were such people. So I don't know what you guys do, right? So it's beyond my thinking capability. So if I was a chapri like you, probably I would have advised, but I'm not, unfortunately. So I can't advise on that. Okay. So similarly, you can do the other options. Negative velocity object is between focus and pole. So for B part, where will you be? For B part, where you will be, negative velocity object is between focus and pole. Focus and pole. Focus and pole. That is somewhere over here. That is somewhere over here. That is somewhere over here. This is the scenario between the focus and the pole. So if you are between the focus and the pole, what do you think will happen? What do you think will happen? If you are between the focus and the pole, I have a feeling if you are here and if you bring the object towards the right side, the image will grow bigger and it will go towards the right side. Think about it. If you're talking about this last case where the object is coming this way, you will see the virtual image. You will see that the virtual image will go towards your right side. Will go towards your right side perfectly. So, my dear warriors, what should be the correct answer for this? Okay. For this one, the image velocity will be positive. Image velocity will be positive. And the size of the image is also going to increase. The size of the image is also going to increase. Perfect. So that is for B. Similarly, do it for C and D. Similarly, do it for C and D as well. Yeah, similarly do it for C and D as well. Yes. What will it be? You figure it out and see if it is matching with P and S and P and R. Okay, C is going with P and S. C option is going with P and S. C option is going with P and S, and your D option is going with P and R. D option will go with P and R. That is this one. So that's how you will mark it. Okay, it's just straightforward from this particular ray diagram. So that's why I say and I make my students practice these ray diagrams for concave convex mirrors, concave convex lenses. You should know it in and out. You cannot say this I did it in 10th standard. What nonsense is this? You can see this nonsense only is helping you solve this JEE Advanced problem and guaranteeing you a seat. So practice that. Okay. We have some homework questions for all of you. So this is the first homework question. This is the first homework question. Okay. So come on. You are going to post the answers in the comment section after the video ends. I think there is one more homework question. Yes, the half-life is this much. How many years will it take for 1 kg of radium to lose 1 milligram? Very interesting question. Answer is there on the next slide. Okay, that's it from this particular lecture. I hope you learnt a lot of new things which otherwise you would have missed in your coaching books, NCERT, etc. Plus, you gained that confidence on how we approach these modern physics and ray optics problems. tomorrow we will do some tough, tricky questions from JEE Advanced, which will boost up your preparation even more. Because no matter whether you are a 90 percentile, 91 percentile, if you feel, no sir, I am from this category, my knowledge is not that great, I want to get into IIT, I need to study hard because I know everybody is studying hard, tomorrow's lecture is for you. So make sure you attend it, and day after tomorrow we will have mock test of JEE Advanced, and then short questions, and all of those things will follow. Okay, so be there. This week is going to be very intensive for JEE Advanced. Do not miss any classes. Make sure you are liking, commenting, also showering your love by spreading the word about this channel. Okay, bye bye. This is Captain Shreyas signing off. Hasta la vista. Join the Telegram group for getting the PDF.